So welcome back. We're going to continue working with exponents, and in particular we're going to work with these rules of exponents that we have been talking about. So one thing we kind of said is typically repeated multiplication, we're allowed to use what we call exponents to represent that. But we also discovered that there are some special exponents, like if I have a negative exponent, that actually means to take the reciprocal, flip the value. We also learned that 0 is a very special exponent as well. Anything raised to 0 power is going to equal 1. And this property here is very much like this property here. Notice how you have what we call a power to a power. If we have two things inside here raised to a power, we're allowed to bring this outside power, we're allowed to distribute it to the inside powers using multiplication as well. So I can get something that looks like this. And we may come across that later on. Let's just turn our attention now to a couple examples. So again, the directions are going to be to simplify. And also what you'll see, most time your answers should not contain negative exponents. Okay? So a lot of times when we do our math, our final answer right now, they typically don't want that negative exponent to be there. So we want to make sure our final answer does not have a negative exponent. Okay? That's just following the instructions of the question. So I have m to the fourth times then 2m to the negative third. So the first thing I pick up on, this is all multiplication. And remember, multiplication order does not matter. What I like to do when I have multiplication is I like to have the numbers first and I like to have the letters second. So the first thing I'm going to do is change this to 2 and then m to the fourth times then m to the negative third. So I'm going to move the 2 around up front. The next thing it says, your answers should not contain negative exponents. So notice how the m to the negative third, it's got that m is raised to the negative 3 there. So to get rid of that negative exponent, what I want to do is move that to the denominator. I'm going to make a fraction out of this. So this is going to change to 2m to the fourth over then m to the third power. Now I want to kind of simplify this. And what I pick up on, the 2 is going to stay there, but over here, what I pick up on is, if I have 4 m's on the top and 3 m's on the bottom, I should be able to pick up on that I'm dividing 3 of those m's. So I can look at this as 2 times m times m times m times m over m times m times m. So we pick up on that we're taking away. And what we're left with is just a 2 and an m. So that's my process. But also don't forget, I could also do this problem as 2 times then, notice how I have a m to the fourth raised to the m to the third. Notice how those have the same base. I could change that to m to the 4 minus 3. I can apply this rule here that says if you have the same base, you can subtract those exponents to simplify it. So if I have the same base, I can write that as m to the 4 minus 3. So it's going to be 2 and m to the first power. But we really don't have to write m to the first power because anything to the first power is just that thing. So I can just write that as 2m. So that would be my simplified answer. Okay, so one way is I could break it down in this type of process, divide out the m's, or I can actually apply the rule that says if I have division, I'm allowed to subtract those exponents to get the answer. Let's look at this next example. I have x squared times y to the negative fourth. Notice how there's not a multiplication symbol there, but we understand that if there's a letter next to a letter, that is understood to be multiplication. So x squared times y to the negative fourth, that is multiplication symbol, times x to the third times y squared. So what I pick up on is, again, everything is connected by multiplication. Since everything is connected by multiplication, we're allowed to move things around as we see fit. The first thing I pick up on, though, is no negative exponents. So this y to the negative fourth, I'm going to move that to the bottom. So I'm going to have x squared times x to the third times y squared on the top. And I'm going to have a y to the fourth on the bottom. So to pick up on it and simplifying this, x squared times x to the third, that meets this condition. If you're multiplying, you can simplify that by simply adding those exponents together. So that's going to be 2 plus 3, which is going to be x to the fifth. And here I have 2 y's on the top and 4 y's on the bottom, so I'm going to be dividing out, taking away. And I'm picking up, I have more y's on the bottom than on the top. So I should have a y squared left in the denominator. Or again, you could go 2 minus 4 and get a -2, but that tells you to bring it down to the bottom as a y squared. A lot of times what I will see though, there's 2 y's here, there's 4 y's here, so I'm mentally marking out 2 of them, and I'm mentally seeing there's 2 y's left in the denominator. So I'm kind of seeing this without actually writing it down on paper. But again, we could use a lot of other patterns here. We could be subtracting those exponents if we want. But a lot of times with division, this is more of how I see it. I really don't subtract exponents there. But with the multiplication, I would add those together and get my 5. So let's see if that helps out a little bit as we move on. So stay tuned.